All right, good morning. My name is Dan Friedman. I'm a data center technical solutions architect at Cisco. I support partners in the Pacific Northwest of the US. This presentation is intended to be an introduction to Intersight service for Terraform, suitable for both business and technical audiences. So let's go ahead and get started. First, we're going to talk a little bit about what is Terraform and what is Terraform Cloud for Business. For those that may not know, these are important sort of foundational knowledge that you'll need to have before trying to understand why we need a tool like Intersight Service for Terraform, the types of problems that it solves, and then we're going to cover what is Intersight Service for Terraform. We'll talk a little bit about the architecture, and then I'll point you at some additional resources. So when we talk about Terraform, when Terraform first got its start, it was basically just an individual binary that you could download and execute on your local laptop. And so at the very top, we say that this is a local execution environment. OSS stands for your open source software version of Terraform, which is this binary I'm referring to. And you download it and you would execute this command on your laptop, or variations of the Terraform command to achieve different things. We're going to talk about those commands coming up. Now, a lot of people sort of confuse Terraform and Ansible, or how they're different, how they're the same. They're both tools related to infrastructure as code, but they're typically used for different things and they operate in different ways. Terraform uses a declarative syntax, which means you don't specify one command at a time. You specify an end state that you're trying to reach. You give that end state in the form of a text file to an application programming interface, which then deciphers the text file and does all the heavy lifting for you by figuring out what are the dependencies, which resources need to be created before which other resources, and so on. So that's what we mean by declarative. Terraform also, after it provisions a bunch of resources, is going to keep a local state file, which is information about the resources that you created. So a good example of that would be, when you create a virtual machine in the public cloud, it'll come back and it'll give you an actual, logical ID number for that machine, and it'll tell you what all the specifications are. All that information is stored in the state file. And, Terraform is usually used for creating infrastructure, and especially given the example I just gave, Terraform really got its start provisioning infrastructure in public cloud environments. So that's typically what people think of. Although nowadays, there are plugins that allow us to also provision on-premises infrastructure. We're going to talk about that coming up. Now, Ansible is not declarative. Instead, it's imperative. So it's still a script. It's still a text file format. But the way that the script is written is to use a module to execute a certain type of command or a certain type of instruction against a remote system. And you provide those instructions one at a time, and you can execute those instructions either in serial or in parallel, depending on your specific needs. But it is procedural and kind of specified one command at a time. Ansible also doesn't store a state file. The state of the remote system that it is trying to work against. When you run Ansible against a target machine, if it is asking for a certain type of configuration and that configuration already exists on the target machine, then Ansible is not going to do anything. But if the target configuration, if the actual configuration of the resource deviates from the state requested in the Ansible script, then it's going to go ahead and update the system. Still, no return values other than for debugging really come back through Ansible. And Ansible is typically used for configuration management of the infrastructure once it's already been created. So these two tools are, they're both tools related to infrastructure as code, but they're typically used for different purposes. Typically, you'll use Terraform to create the infrastructure, and then Ansible to, layer software components and stuff and configuration on top of that infrastructure. Okay, Terraform also uses what's called provider plugins, and basically what Terraform does is it makes API calls against a remote system, and those API calls are what result in the creation of infrastructure within that system. So there are provider plugins for all of the common cloud service providers. So we've got a plugin for Amazon Web Services and Azure and Google and a whole bunch of others. Now we also have provider plugins for things like vCenter, Pure Storage, ACI, Cisco ASA, all kinds of different plugins. So each plugin, like the AWS plugin, will provide all of the API calls necessary to create all kinds of different resources in an AWS environment. So all of the plugins can be browsed at this URL, and you can go check out for yourself what is available. Now, in terms of files and modules, the way that we write Terraform code is in files. And so I've listed 4 files here. We've got main.tf, variables.tf, terraform.tfrs, and terraform.tfstate. Now, main.tf, the idea here is that this is where you're going to write most of your code that creates different types of resources on whatever target system it is that you're trying to provision resources on. Now, it doesn't have to be called main.tf. That's just a typical file name by convention. Nor does it have to be a single file, right? So the idea here is that you can create multiple different files. Maybe you're going to call them site1 storage.tf, site1 network.tf, and site1 compute.tf. The idea is you can name these files and you can divide them up into as many different file names as you want to organize your code. When you actually execute Terraform, it's going to merge all these commands together anyway. So it's purely for organizational purposes. The variables.tf file is where you declare the existence of a variable, and the terraform.tfvars is where you assign value to each of the declared variables. So it's in the tfvars file that you will typically edit the specific values that you want to be used when provisioning your resources. And a lot of times this file can contain things like, target system URLs, API keys, usernames, passwords, secrets, all that kind of stuff. And then finally, once your Terraform execution has actually created its resources, then it's going to update the terraform.tf state file with, records of the resources that were created. Now, modules are a way of writing your code and variables in a way that makes it easily reusable by someone else. You can literally put those files. A module usually refers to a subdirectory in your project that contains both files similar to like main.tf and variables.tf. So anyway, this isn't meant to be a deep dive on Terraform. You can learn more about that in the Terraform class. I'll point you at a great class in the resources. Now, blocks are like the different chunks of code that you're going to put into your main.tf or similar files. The first one is called required providers, and this one basically just says which provider plugins do I need to download onto the local machine so that when I run my Terraform code, it can actually make those API calls against those target systems successfully. The providers block is what allows you to configure connectivity to that provider, right? If you download the AWS plugin, that's great. You have all the logic to make the API calls, but you need to make them against a certain account. And so it's under the providers block where you basically would specify like a username and a password or an API key and those types of parameters so that you can connect to the specific billing account under which you want to provision your resources. The data block is meant as it's like a read-only type of resource. It allows you to retrieve information about a particular resource that's already been created on your target system. So maybe you need to pull back, the ID of a storage account where you're going to tie that storage account to a new resource that you're going to create. And that's what the next block type is the resource block. This is the most commonly used type of block in Terraform because it's what allows you to create all different types of resources. And, a resource is just an object. So all of these objects get linked together. A VM gets linked to a public IP, and it also gets linked to a storage, virtual disk. And each of these objects have IDs. So that's the example I was giving with the data ID. Maybe I needed to pull the ID of an already existing public IP because I want to assign that particular public IP to a new virtual machine that I'm creating with my resource block. So that's how those two would work together. And then finally, an output block allows you to basically print out relevant information that you would be interested in after Terraform finishes executing. So for example, if you've written your Terraform code to deploy a new virtual machine and you want that virtual machine to have a new public IP, you don't know what that public IP is until the virtual machine public IP has been created, bound together, and are like booted and operational. Only after that can we then send the public IP as output back to you, the user, because that would be interesting output for you. Now, in terms of commands, there's a number of subcommands to the Terraform CLI, and we mentioned that all of your files are going to be held within a working directory. So basically, you would write up all your code, put it, sort it into your different TF files, however it makes sense for you, and then you would run a Terraform init inside that directory. And what that's going to do is read your code files, go look for the required providers, and download those plugins. Then you can do a Terraform FMT, which stands for format. And what this does is, you may not have like cleanly formatted your .tf files. Maybe you've got different levels of indentation, and you're just trying to basically clean it up and make it look as pretty as possible. So that's what Terraform FMT will do. Terraform Validate will essentially look at the combination of all your different .tf files and try and understand any dependencies. So just like I was referring to earlier, a virtual machine needs a virtual disk. Wants to make sure that you've accounted for that virtual disk before you try to create the virtual machine. And if you haven't in your code, then your validation would fail. Something along those lines, right? This is about making sure that the overall logic of your code makes sense and any dependencies have been met. Now that we've done those commands, we kind of enter more of the Terraform process, which really applies directly to the plan, apply, and destroy commands. So if you now run a Terraform plan against all of the code that lives in this local directory, what it's going to do is it's going to read all those files, it's going to check your state file if one exists, and it's going to say, what changes do I need to make in order for the resources declared in my .tf files to become active, essentially, right? So this is not actually going to create those resources. It's sort of a preview of what's going to happen. Am I going to add, update, or remove various types of resources based on what's in my TF files? The apply command, Terraform apply, does two things. It's going to create resources and it's going to update resources. Now, again, if you've never run Terraform apply in this particular directory where you've just done your project init, then you're not going to have a TF state file yet. That's only going to be created after you run TF apply for the very first time. Resources are created, the execution finishes, and then the TF state file is updated with that information. So in this case, anything that was in the .tf file would basically be created and then updated in the TF state file. But what if you're on your second run? Some of the resources in your .tf files may not change at all. You may add a NIC to a VM. You might remove a NIC from a VM. So these are called updates, right? If you add a NIC to a VM, that would be considered an update, not a create. You've already created the resource. Now you're updating the VM, right? Same thing if you remove a resource. Now, removing a VNIC from a VM is not the same thing as destroying the VM altogether. So Terraform destroy basically takes a look at what's in your state file and it goes out and it actually tears down all of those resources in your public cloud or whatever target system it is you're provisioning or deprovisioning resources on. So the apply and the destroy commands are often used together in a scenario like a dev test environment where you're regularly spinning up new infrastructure, running through a series of tests, and then you want to tear it all down and do it all over again. So this is where destroy can be useful. And if you have lost your TF state file, then you have no simple way to go and delete all those resources. Now you've got to go to your cloud service provider UI and basically, walk the chain and delete them one by one. So this is a much more efficient way to get rid of your resources quickly. And then finally, the Terraform show command is going to read your TF state file and allow you to understand, what exists in your cloud without having to basically go peruse the UI and see it. Now, we mentioned at the very top of this slide that, the Terraform binary that you download to your local laptop, you're executing it locally. And so that means that this is essentially a local execution environment, but there are other execution environments available. So OSS refers to the open source software version of Terraform, and that's the local execution environment on your laptop. But there's also Terraform Cloud for Business. So that's what we mean here by cloud. And there's also Enterprise. And really the only difference between cloud and enterprise is that the cloud version is a SaaS offering where everything is hosted by HashiCorp. And enterprise means that you would essentially have to install and manage that infrastructure yourself. So we're really going to focus on Terraform Cloud for Business in this particular presentation. All right, so what is Terraform Cloud for Business? Well, we mentioned the local execution environment for the binary, but there's some particular problems with that we're going to get into on the next slides. But mainly, Terraform Cloud for Business is a remote execution environment, which means that the commands or process for plan, apply, and destroy are run in the cloud SaaS infrastructure. And there's some terminology you need to be familiar with so that you can basically, get your hands dirty with Terraform Cloud for Business and be effective. And so I'm going to go ahead and kind of cover a few basic concepts. Organizations are a shared space for teams to collaborate on workspaces. And it's like, well, what are teams and what are workspaces? We're going to cover that coming right up within Terraform Cloud. And so the idea behind organizations is essentially multi-tenancy. And since typically it's going to be, your company goes out and purchases a subscription for Terraform Cloud for Business, the concept of multi-tenancy here really points to maybe different business units within that enterprise or corporation. It's not really multi-tenancy in the sense of, multiple different customers. So maybe you have a portion of your organization that is responsible for your storage infrastructure, or another organization responsible for your network infrastructure, or maybe that's not how it is at all. Maybe you have an organization that's responsible for maintaining all the infrastructure for a particular application. So you can really carve this up however it makes sense to you. Now, teams are groups of Terraform Cloud users within the organization. So, by default, you create an organization and then you can start creating users in that organization. And the users can just belong to the organization, or then you can start creating them and creating teams and adding users to the teams. So to delegate provisioning work, the organization can grant workspace permissions to specific teams. So ultimately, you want to put your users into your teams so that they can get permissions to conduct provisioning work. Users, as we mentioned, that's pretty obvious, are accounts that belong to individual people. And then for organization and team membership, you have to be invited by an owner of the organization. So like I said, users exist within an organization. So if the admin user creates an account for you in the org, then you have essentially been invited. To have any permissions within the organization, an owner needs to add you to one or more teams. All right, so permissions basically refer to Terraform Cloud's access model. And as has already been mentioned, this is team-based. So in order to perform an action within a Terraform Cloud organization, users must belong to a team that has been granted appropriate permissions. Now, the permissions model is split into organization level and workspace level permissions. And additionally, every organization has a special team named owners whose members have max permissions within the organization. So you can just think of this as like your administrative or super user who can kind of control everything so that we don't wind up locking ourselves out. All right, finally, workspaces. So working with Terraform involves managing collections of infrastructure resources. What do we mean by that? For example, a collection of infrastructure resources might be storage or network or compute. And most organizations manage many different collections. These could be collections per location or per environment, and also the system type, storage, network, compute, like I was kind of providing an example to earlier. So when Terraform is run locally, it Terraform then manages each collection of infrastructure within a persistent working directory. So again, this is the directory in which all your TF, TFRs, TF state, in which you ran Terraform init. That is the persistent working directory we're talking about here. And it contains the configuration, the state data, and the variables. And since Terraform CLI uses content from the directory that it runs in, you can organize infrastructure resources into meaningful groups by keeping their configurations in separate directories. But when you use Terraform Cloud for Business, there are no directories. So instead, there's a new construct called workspaces that we use as instead of directories, in place of directories. A workspace contains everything that Terraform needs to manage a given collection of infrastructure, and separate workspaces function like separate working directories. So hopefully that gives you a basic background on some terminology that will be pertinent to getting up and running with Terraform Cloud for Business. But there's a few other considerations. One, you're going to need source control repository, right? A storage location for your Terraform code. Ultimately, this is going to get connected to a given workspace. And then, what we need to do when we're talking about on-premises equipment is we need to be able to extend the execution environment to on-premise. And so we're going to talk more about that as we get into the architecture conversation coming up. So why do we need a tool like Intersight service for Terraform? And the simple answer is we need it for provisioning on-premises equipment. If we've got our TF files out in the cloud and we have, let's say, an ACI fabric on-prem, well, how do we connect to that on-prem equipment without a bunch of problems? And we're going to kind of talk through some of those problems here. But before we do, the entire intent here, right, is to automate provisioning methods to scale hybrid cloud efficiently via machine-readable definition files rather than interactive tools. So this really speaks to why we're using Terraform in the first place. And the fact that we want to be able to leverage Terraform not just against our public cloud providers and resources, but also against our private cloud resources. Now, we already talked about, these two different versions of Terraform. We have the open source software version, which is a local execution environment on your laptop. And we also have Terraform Cloud for Business. And the reality is each one of these has its own set of limitations. So, when we think about running the Terraform binary open source version on our individual laptops, this doesn't lend itself very well to collaboration, right? Because all of the code for the resources that you want to create and the state file of the resources that you have or haven't created, it all exists on your local laptop. And so nobody else has visibility into what you're working on. On top of that, right, the security of the code, of the state file, and of any secrets that may be in clear text, for example, in your .tf-vars file, security is a concern. Also, when you're running a tool from the command line, it can be a lot more difficult to integrate the work that you're doing there with any kind of larger process via integration with CI/CD. And then also, since this is an open source tool, there's really no good support model for this, right? Who's going to support you when things don't work? And especially when you're now using Terraform to manage a very large production environment, this is something that you probably are going to want some help with. So those are some of the limitations that we are solving with Intersight service for Terraform. Well, actually, all of those things there are problems that are solved by Terraform Cloud for Business, right? So we'll talk a little bit more about that. But then Terraform Cloud for Business has other of its own limitations. So, for example, we talked about this need to have the code that exists within Terraform Cloud for Business talk to our equipment that is on premises. So if that was an APIC, for example, for a Cisco ACI fabric, what we mean here is that we would have to poke a hole in the perimeter firewall in order to allow Terraform Cloud for Business to talk to the management IP of our APIC. Now, no architect and no security person is going to say that that's a good idea. It's not, right? It's not secure to expose your internal data center management IP, screen where you would literally log in to the public internet. So the way that Terraform Cloud for Business gets around this is to have you, the user, set up a Terraform Cloud agent on premises. So, what this does is it'll make an outbound call to Terraform Cloud for Business, very similar to the way that the Intersight Assist appliance makes an outbound call to intersight.com. Cloud Agent works the same way, and so it sets up a tunnel of communication between Terraform Cloud for Business and the Cloud Agent on-prem, thereby extending that execution environment on-prem. But now the Cloud Agent, you have to set it up, you have to upgrade it, you have to scale it. There's this operational burden and management effort that comes along with doing this. And on top of that, the Cloud Agent runs as a container. And what that means is that there's a whole other layer of stuff that you may potentially have to deal with that you may not know how to deal with. Setting up a container runtime environment to even be able to run a Cloud Agent might include something like setting up a Kubernetes cluster. So if you don't already have that environment set up or the skills to do it, this can be a real challenge for users of Terraform Cloud for Business. And these are the types of problems that we want to solve. So what is Intersight Service for Terraform? It is the tight integration of Terraform Cloud for Business with the Intersight service. Now, we said, right, that we're aiming to solve a number of problems, and Terraform Cloud for Business solves the problems that are listed here, right? It makes sure that collaboration on code is much easier. So you've got centralized visibility, and you've got state file management and sharing, meaning that everyone on your team can now see the .tf files and the .tf state file, making it easier for me to understand what you've done and you to understand what I've done, and all of the configuration files, the .tf files, as well as the results, right? The actual business outcome in the .tf state file is all stored and visible centrally to an entire team. So it makes collaboration a lot easier. Also, we've got advanced security and compliance. So there's an SSO integration between TFCB and Intersight. And we also have role-based access control, organizations, teams, users, workspaces, and all those other constructs that we said you can really design in whatever makes the most sense for your organization, as well as secrets management. So we had said that in the .tf-vars file, you can often have some clear text passwords, and that's not really great from a security standpoint. So Terraform Cloud for Business has a secrets management capability built right into the platform. So, you can enter your secret and you can literally never see it again if you don't want to. But you can pull the value sort of like from, I believe it's called Terraform Vault, or any other type of security credentials vault type solution where you say, I need to access the secret associated with this key, and you never really know what the secret is, but the value gets plugged in where it's needed. So anyway, a nice way to be able to store your secrets in a secure fashion. And then finally, performance and scale. And this really boils down to wanting to be able to handle multiple concurrent runs of Terraform. And this boils down to, how frequently are you changing your infrastructure or provisioning new resources or whatnot. So the way that Terraform Cloud for Business handles this is to deploy multiple Terraform agents on-prem, and then each agent can be a point of execution, meaning you can handle multiple concurrent runs that way. All right, so what is IST architecture? The components, we're just going to kind of go down the list, right? You've got to have a Terraform Cloud for Business SaaS subscription. So you've got to have an account. You go in, you create your organizations, your teams, your users, your workspaces, and so on. You're also going to need an Intersight SaaS subscription. And specifically on this one, you're going to need the Intersight Advanced license in order to be able to run IST. And once you've got your Intersight account, then you can claim your Terraform Cloud for Business account. So you'll be asked to, point at a specific organization, provide your credentials, and so on. And that's how you stand up the relationship between these two systems. Now, on premises, you're going to deploy your Assist appliance. And remember that this is typically used for what you do is you claim this appliance, and it's used as a reverse proxy to speak to third-party equipment like vCenter or Pure Storage Array that exist in your on-prem site. So typically you deploy an Assist appliance per site, and then it calls home and gets claimed into the Intersight SaaS platform, allowing you to access your on-prem gear. Now, as part of Intersight Service for Terraform architecture, what you do now is you install the Terraform agents right on the Assist appliance instead of having to set up a separate runtime environment. The Assist appliance basically provides this for you. So within the Assist appliance, you basically have a single node Kubernetes cluster capable of running containers. So you can now run one or multiple agents right there on the Assist appliance without having to create that runtime environment or deal with that extra layer of management burden. Now, what's really cool about this is that when you claim the Assist appliance in under Intersight and the Terraform agents are running on the Assist appliance, all of them, the Assist appliance itself and the agents running there, become lifecycle managed through Intersight, meaning they're kept up to date, and there really isn't anything that you need to do to make that happen. So this is a big value add. It really simplifies the architecture for IST. For most on-premises use cases, you're going to have Assist appliance already there anyway, and the architecture for Intersight is very simple. So we're just leveraging the Intersight architecture to allow Terraform Cloud to speak to local resources. Now, with regards to public cloud resources, right, since TFCB is a SaaS offering, it exists out on the internet, it can communicate directly to public cloud service provider APIs and create those resources with no restrictions where it comes to traffic flow, right? It's all publicly routable. But when we're trying to use Terraform Cloud for Business to provision resources in our private cloud, well, we're going to have like a perimeter firewall there, right? And so there's some limitations or challenges that have to do to enable that communication. And so we're going to talk through that using a visual on the next slide. Finally, with Intersight Cloud Orchestrator, you can make callouts to Intersight Service for Terraform, meaning you've got a workflow, a larger process, and within that larger process, you need to use Terraform to do some work in order to achieve the overall business outcome for that entire workflow. And so you can invoke a web API request task back to Terraform Cloud for Business to execute some code. And then obviously when that execution is done, it will hand the process back to Intersight Cloud Orchestrator. So just be aware that you can integrate Terraform with a larger orchestration engine and set of workflows. So this diagram here is kind of a high level on the architecture. So up here in the center of the diagram, we have TFCB, Terraform Cloud for Business. And then over here, we have Cisco Intersight, Intersight.com, right? And Terraform Cloud for Business subscriptions. And you claim Terraform Cloud from Intersight, which establishes this bidirectional communication between these two SaaS platforms. Now, if you haven't seen my Introduction to Intersight presentation, you should probably go check that out, because that explains how Intersight is able to manage equipment in all of your locations. Specifically, it can manage Cisco equipment like UCS or HyperFlex directly because it's Cisco equipment. But for non-Cisco equipment, we deploy the Intersight Assist, and that's because Cisco equipment has a device connector built right into it, and that's the component that makes the outbound SSL tunnel connection back to Intersight.com. But third-party equipment like Pure Storage and VMware, they're not going to have that device connector in their software, nor are they going to put it in there. So we put it into the Intersight Assist virtual appliance, we claim that, and we use this as a reverse proxy to gain access to all of our third-party gear. Now, you're also going to see here that this is where we're running our Terraform Cloud agents. And there is a limitation of running 5 cloud agents per Intersight Assist appliance. So if you need more than 5 concurrent runs because you've got a high rate of change in a particular site, then you're going to want to run more than 1 Intersight Assist appliance per site. So this is how you would communicate with your on-premises equipment. Now, if you wanted to provision resources in your public cloud, again, all of the traffic between Terraform Cloud, publicly accessible SaaS hosted service, and our public clouds, this is all internet routed traffic. It's all publicly exposed, and the APIs are there to be consumed directly by Terraform Cloud for Business. So essentially, IST securely integrates with Terraform Cloud. It extends infrastructure as code across both private and public cloud, as we can see here. So really, this is intended to be a hybrid cloud solution, allows you to provision resources regardless of their location in following the same method. And this also helps bridge the gap between DevOps and IT Ops. And that really refers to the fact that Intersight has its own API. So IT Ops needs a simpler way of handling things. DevOps may wish to programmatically manipulate the infrastructure, can do so using the Intersight API. All right, so this is a diagram that I put together, and to describe, I think it does a good job of describing kind of the different infrastructure components, how they all communicate. So starting over on the right in orange, these are different types of infrastructure resources that we may want to create, whether they be in the public cloud or in the private cloud. In public cloud, talking about consuming AWS, Azure, or GCP APIs in order to create resources. In the private cloud, we're talking about consuming ACI, Pure, VMware, Kubernetes, or Helm APIs in order to create resources. So regardless of location, the goal is to create these resources. And anything that you see in green is essentially a component of Terraform Cloud for Business. So we see the SaaS service account that we've created along with our organization and our workspaces located up here in the upper left. And what we said is that, without these Terraform agents, in order to configure resources on-prem, let's say that this orange box here is an ACI fabric. In order to configure that ACI fabric, we have an API that lives on the APIC. We would need to expose that IP through this firewall to allow Terraform Cloud for Business code execution to reach that resource. And, this is not a recommended approach. So what we do is we deploy Terraform agents on premises, and these guys establish an outbound connection through the firewall back to Terraform Cloud for Business. And then this establishes a bi-directional communication tunnel from Terraform Cloud all the way down to the agent. And that thereby extends the execution environment. Any code executing here can then be pushed onto the agent and executed locally against the APIC. Now, the trouble with this, like we highlighted before, is that you have to install, update, maintain, and troubleshoot these agents, and also the runtime environment that they run on. So what we want to do with IST is simplify this story and make that easier. So here we've added in the IST offering and basically trying to show how it architecturally fits. So again, you would create an Intersight.com account, get the licensing you need for IST, and then you would claim Terraform Cloud for Business, which establishes this SSO and API reverse proxy functionality routed over the public internet. Of course, it's a secure channel. And then, we're going to deploy an Assist appliance on premises. And the Assist appliance is Cisco specific. It makes an outbound call to Intersight.com, and then a permanent SSL tunnel is stood up there as well after that claim is basically authenticated. Now, the Assist appliance is where these Terraform agents run. They run directly on the appliance. So I maybe should have made these icons a bit smaller and nested them within the blue rectangle to really show that the agents are running on the appliance, but you get the idea. That's really why I drew this blue circle around here. The blue circle is the Assist appliance, and these agents are running right on that appliance. So, here we can see how the communications path gets established without having to poke any inbound holes through your perimeter firewall all the way back to Terraform Cloud for Business. And this is what we mean by extending the execution environment. Now the code can be basically proxied through Intersight, the Assist appliance, down onto the agent, and then the agent will execute API calls against local resources like your ACI fabric. One other piece that I haven't really explained yet, right, is the source control. And so we did talk about workspaces and how those can be set up to manage different types of infrastructure. So for example, maybe the blue workspace is tied to repo 1, and repo 1 is Terraform code for creating, let's say, an ACI tenant. So you would tie your workspace to repo 1, and then the workspace is going to get tied to a particular TF agent. And so this agent in Site 1 would be responsible for configuring basically these network resources stored in the code in repo 1. And so this API, maybe this orange box represents the APIC, right, for the ACI fabric. Whereas repo 2, this is where your storage team might be uploading Terraform code to create, volumes and such on a pure storage array. So you would then connect repo 2 to a totally separate workspace. Again, remember that, maybe you assign a certain team, the network team, to the blue workspace and the storage team to the gray workspace. So you're giving that team access to the code that they need and ultimately tying that workspace to another specific Terraform agent, and this Terraform agent then talks to the API on the pure storage array. So it's a way of controlling who has access to manage what infrastructure. So anyway, source control is a component of the overall solution that you need to factor in. Now, another way to configure resources is with the Intersight Terraform provider. So I mentioned that Intersight has an API, and therefore Terraform code executed within Terraform Cloud for Business can talk directly to the Intersight API as it would any other API. And this can accomplish two things. A, it can configure items natively to reach Cisco equipment. So anything that's really managed through Intersight, like pools, policies, templates, server profiles, domain profiles, chassis profiles, Kubernetes profiles, etc. All of these things can be coded up inside of Terraform and then executed directly against the Intersight API. Configuring items via the Assist appliance to reach third-party equipment is another thing, right? So again, you would be executing this Terraform code against the API, and in the case that was Cisco managed, then basically it would forward that traffic directly over to those resources that it manages. Otherwise, it may have to go through the Assist appliance in order to reach its destination. And then finally, with Intersight Cloud Orchestrator in the upper left corner, we've got a workflow here. It's got 6 tasks, and after task 1 is completed, we decide we need to do some work with Terraform. So task 2 makes a call out, and this is that invocation of the web API request that we had talked about. And it's going to go out to Terraform, and maybe it's going to execute the code tied to workspace blue, which is Terraform agent, and go against the APIC, right? So in that way you can do some configuration on the network, and then once that configuration is done, you can hand the results of that execution back to Intersight Cloud Orchestrator and proceed on with a larger workflow. So just keep this in mind, that this is a way that you can integrate Terraform with a much larger process. All right, in terms of resources, first you're going to need an account on intersight.com, so I provided that link. And then you're going to need licensing on Intersight platform. So if you go to intersight.com/help, you can look, I think it's under Getting Started Licensing. You can look at the different licensing that you may need. Again, you'll need the Intersight Advanced license, or I think it's Advantage license in order to run IST. Now, if you don't have familiarity with Terraform, then I highly recommend the HashiCorp Certified Terraform Associate class. I took this class. It used to be hosted on Linux Academy, which was acquired by A Cloud Guru. So it now runs on their platform. But this was a great class to get you familiar with basic Terraform concepts. They give you labs so you can kind of practice your commands. I thought it was very effective. Next, you're going to need a Terraform Cloud for Business account. And yeah, you're going to go in, you're going to create your organizations, your teams, your users, your workspaces, hook that up to Git. You're going to claim a Terraform Cloud agent, and you're going to specify which Intersight Assist appliance you want to install that in a given location. And then you're going to tie your workspace to that particular agent for deployment efforts in that location. Something that I should mention, right, is that Terraform Cloud for Business is available for purchase straight through the Cisco GPL. And when you purchase it through Cisco, it comes with full support. So I did mention earlier on in the presentation lack of a support model for the open source version. This entire stack is fully supported by Cisco. Now, if you want some additional education, you should go check out dCloud. So that link will take you to basically a virtual lab that allows you to understand more about how Terraform works in an Intersight environment. And then finally, you can download the Intersight Terraform provider. And again, that's what would allow you to write Terraform code that would execute directly against the Intersight API. So I hope that this was a useful presentation. If you have any questions, feel free to reach out to me. Again, my name is Dan Friedman. I'm a data center TSA at Cisco. Thanks for taking the time to watch. I hope this was useful.